In this video, we're going to look at inequalities. We're going to remind ourselves of what an inequality is and how we can represent inequalities on a number line. So first of all, an inequality is an algebraic statement of giving a range, and it involves one of four symbols. We have this symbol, which means bigger than or greater than, and the bigger number always goes next to the open side of the symbol. So we might have, for example, 7 is bigger than 3. The next symbol is this one, which is smaller than or less than, and in this case we might have that 2 is less than 5. Notice that the bigger thing goes next to the open side of the symbol. The other two symbols are exactly the same, but they have a line underneath them, and the difference with those is that they mean that it could be bigger than or equal to. And similarly, this one means smaller than or equal to. Now, when we're comparing numbers, it doesn't make sense to be talking about bigger than or equal to, but we'll see later on in this video that when we apply it to algebra, it makes more sense and gives us an extra option. So let's have a look at some examples with some algebra in. So here we have the inequality x is bigger than 3, or x is greater than 3. And what that means is the value of x could be absolutely anything that is bigger than 3. So x might be 4, or it might be 3.2, or it might be 751, or it might be 5 2/3, and so on. It could be infinitely many different things. Any number we like, decimal or fraction, as long as it's bigger than 3. So we can't write down every possible answer, and this is why we use this notation, because this tells us that x could be anything as long as it's bigger than 3. We can also represent it on the number line, and the way we do that is we draw a circle over the number 3, and we want all the values that are bigger than 3, so we draw an arrow pointing in the direction that is bigger than 3. Let's take a look at the next example. This example is very similar, except it's x is less than or equal to 2. So in this case, x might be, could be anything less than or equal to 2, but because it's got that line underneath, it could be 2. It could be 1.5. It could be minus 72. And again, the number of things go on forever and ever. There are infinitely many numbers we could say that this is. So this time we put our circle above 2, and because we want the numbers that are less than 2, our arrow's going to go in that direction to the numbers that are less than 2. Now we must notice there's something different between the symbols. In the previous example, there was no line underneath the symbol, but in this example we have the line, we have the equality part of the symbol, and to show that on a number line we fill in the circle with our pen and colour it in. Okay. Let's have a look at a couple more examples. Okay, this one says that x is bigger than minus 4 but less than or equal to 1. So this time x is in a range. It's less than or equal to 1, but it's bigger than minus 4. And we do this in much the same way. We put a circle above -4, and because that inequality does not include it, it does not have the equality, we do not fill it in. We put a circle above 1, but that one is an equality. It does include the 1, so we have to fill in that circle. And instead of an arrow that goes on forever and ever, we draw a line between them. It's important to note that x might be, in this case, it might be -3, it might be 1, it might be -2.7, it might be 0.4132. And again, although we are restricted within between two numbers, because we can include decimals, the list of numbers that x could be goes on forever and ever. One final example of the different types of inequalities we can get to sketch on number lines. This one is split into two parts. We're told x is bigger than 2, x is less than or equal to -1. In this case, we can't write them as a single inequality because a number cannot be bigger than 2 and less than -1. So we have to do it as two separate parts. X is bigger than 2, so we draw a circle over 2. We don't fill it in because it's not equal to 2, and we want the values that are bigger than that, so we draw an arrow going out that way. X is less than or equal to -1, so we draw a circle over -1. We do want to include -1, so we fill it in. And we want the values less than that, so we draw an arrow in that direction. This time, it's all values that are bigger than 2 or less than or equal to -1. So in this case, x might be, bad spelling there, might be, it could be -1, that's allowed. It could be 4, that's bigger than 2. It could be -5.3, that's smaller than -1, that's okay. It could be 726.4, that's okay. And again, there are infinitely many things. It just can't be anything between -1 and 2. The other type of question we might be asked given an inequality is something along the lines of this. Find the integer values that satisfy the inequality below. -3 is less than or equal to x is less than 4. Now, the first important word here is integer. Remember, integer means whole numbers. Whole numbers could be positive or negative. It's just they don't have a decimal part. So the whole number solutions to the inequality, or let's start at the smallest one, we can have -3 because it has the equal sign. So -3 is allowed. That is a possible whole number solution for this inequality. We could also have -2 because that's between the two numbers. We could have -1, 0, 1, 2, and 3. We cannot have 4 because 4 does not have an equality sign to go with it. You should notice here that there are actually other inequalities that could describe this set of numbers. We could have had -4 less than x less than 4, because that one wouldn't include -4, so the smallest number would have been -3. We could also have had -3 less than or equal to x less than or equal to 3, because that one was the same as the first one but would include 3. And finally, we could have -4 less than x less than or equal to 3. All four of those inequalities would give the same set of integer values. But you must be very careful when you're looking at them to make sure you include values that have an equal sign in the inequality. So that's how we show inequalities on a number line and how we find integer values that satisfy certain inequalities.